Okay, uh, good afternoon, all of you. So we are going to start, like I said, this is the first session of the class 12 chemistry, and we are going to start with the very first chapter of your syllabus, which is called solid state. Now the thing is, in this chapter, at the very beginning, the first thing you have to know is that, broadly speaking, there are two types of solids. One is called crystalline and one is called amorphous. Crystalline means that they will have a definite and characteristic geometrical shape. So it could be cubic, it could be cubical, it could be cuboidal. There are some other shapes like hexagonal, rhombohedral. There are some different shapes which we'll talk about during the course of this chapter, but they will have a definite characteristic geometrical shape. Compared to that, amorphous solids, they will not have any definite characteristic shape. In fact, they will have an irregular shape. Number two, crystalline solids will melt at a sharp characteristic temperature. So they will have a very clearly defined characteristic melting point. Whereas in case of amorphous solids, they will gradually soften over a range of temperature. So amorphous solids, you will not have a clearly defined melting point. In fact, they will soften over a range of temperature. Number three, when cut with a sharp edge tool, crystalline will split into two pieces, and the newly generated surfaces will be plain and smooth. So if you cut it with a sharp tool, then crystalline will cut into two pieces if you cut it, and once you have cut it, the surfaces which are generated, they will be plain and smooth. But in case of amorphous, if you cut it, then after cutting it, the surfaces will be irregular, they will not be plain and smooth. Number four, you know that whenever a solid is melting, there is enthalpy of fusion, or you can just say heat of fusion. So there is a definite and characteristic heat of fusion or enthalpy of fusion associated with crystalline solids. Whereas for amorphous solids, they do not have any definite or characteristic heat of fusion. And crystalline solids, for all practical purposes, crystalline solids, we say that they are true solids, right? We say that they are actually solids, whereas amorphous solids, we don't recognize them as true solids. We say that they are pseudo solids. That means they are actually not solids, they are super cooled liquids. For example, glass is considered a super cooled liquid. And number six is they have long range order, they have short range order. Now, long range order and short range order, what is the difference? That means that if you go in a particular direction, you will find that there is a repeating pattern in crystalline. So, and if you go in any direction, you will find a repeating pattern. So that's why long range order. Short range order means up to a point there might be a repeating pattern, but after that you won't get any repeating pattern. So that is amorphous. So this is the difference between crystalline and amorphous. So crystalline example is sodium chloride is one example, quartz is another example. These are all examples of crystalline. And amorphous, example is quartz, glass. Quartz glass, rubber, plastics, So these are all amorphous, and crystalline is NaCl and quartz. Okay, now there is another property, number 7. That is, if you are talking about crystalline, they are having a property called anisotropic, and if you are having amorphous, then it is called isotropic. So, what is the meaning of anisotropic? That means that anisotropic means the physical properties will change depending on which direction you are going, whereas in case of amorphous, there is no long range order, so physical properties will be the same in every direction. So anisotropic means physical properties differ according to direction, and isotropic means physical properties are same for all directions. So this is the difference between anisotropic and isotropic. So anisotropic means physical properties will differ according to direction, and isotropic means physical properties will be same for all directions. So this is the difference between anisotropic and isotropic. So these are the, broadly speaking, different types of points of difference between crystalline and amorphous solids. Okay. So based on this, I am giving you the homework for today's session. Okay, so the first 3 homework questions for today. first three homework questions for today. The first question is that why are solids rigid? That is the first question for today. So you can say that solids are rigid because the intermolecular forces bring them very close, so that they tend to occupy a fixed position, right? Solids are rigid because the intermolecular forces tend to bring them very close, and they tend to be held to each other by intermolecular forces. And in case if the temperature increases, then also they don't leave their positions, they in fact tend to vibrate about their position. So that is why solids are rigid. So that is the answer of the first question. And second one, why do solids have definite volume? So I guess because of the fact that the molecules do not leave their positions and are held by each other's attractions, and even if the temperature increases, the vibration will only make them vibrate about the mean position. So molecule to molecule distance will usually not change, and since the dimensions are constant, so it has a definite volume. And the third one, you have to answer out of these which ones are crystalline and which ones are amorphous. So just remember what I told you earlier, that glass, plastics, rubber, these kind of objects which are generally classified as polymers, etc. So they will be amorphous and the rest will be crystalline. Like for example, fiberglass, then Teflon. So these kind of substances, they are all polymer, plastic based. So they will all be amorphous. Copper is a metal, so copper will be in the form of crystal. So you have to keep in mind while answering question number 3. Then question number 4. Why is glass considered a supercooled liquid? So the answer will be that the glass does not actually have any sharply defined melting point, and therefore it tends to soften over a range of temperatures, and that is the reason why there is a tendency that you will find that glass actually seems to flow in some cases. Like say for example, if you have window panes of very old buildings, like buildings which are 200-300 years old, so you'll find that the window panes will be thicker at the bottom because glass has a tendency to flow. So that tendency to flow, we say that glass is a liquid and it is super cooled, and that is why it is looking like a solid, because you know that when the temperature is very low, the thermal agitations will be less, and that is when a liquid can be considered as a solid. So that is the answer of number 4. So number 5, the refractive index of a solid is the same in all directions. So what is the type of solid? So the refractive index of a solid is the same irrespective of which direction you are going. So the question is that what is the type of solid? That means you'll have to say whether it is amorphous or crystalline. So these are the 5 homework questions, and you have to submit the homework by 9 p.m. tomorrow. Okay, so I'll end the session for now.